All right. So a couple more things to wrap up our sort of intro chapter. First thing is just having kind of a standard way to draw angles, so what we call standard form. The idea is to essentially have an angle drawn on the XY coordinate system. So if we draw a little XY plane, the vertex is right at the center, at the origin. The initial side is always on the x-axis, going sort of straight east, right? Going in the positive direction. And then from there, right, positive rotation is counterclockwise and negative rotation is clockwise. So if we want to just make a couple like quick sketches, what this does, right, having it on the XY plane sort of naturally breaks it up into 4 quadrants, and that's what we're going to call these. So quadrant 1 is our sort of top right. So if I go kind of halfway, right, this would be sort of a 45-degree angle, or we said this would be pi over 4 in radians. So that's going to be an angle in quadrant 1, right? So that's putting us anywhere between 0 and 90 degrees is going to be that first quadrant. If we go bigger than 90, right, so if we did something like 120, where it would be kind of 30 degrees bigger, 135 would be 45 degrees bigger. Let's go even a little bigger than that to 150. So the idea, right, is that our initial side is always straight out. So maybe I do this guy. So that's going to be 150 degrees in radians. I think we did this one before, but if we didn't, this is going to be 5 pi over 6. And so this takes us into quadrant 2. So just in a positive rotation, right, moving counterclockwise through all the angles, we're going quadrant 1, quadrant 2, and so then this next one must be, of course, quadrant 3. Down in this sort of bottom left. Again, we can kind of draw any angle we want to. What if we do something like this? So this is maybe, so if we sort of count, this is 0, this would be 90, this would be 180. So then maybe we're going 60 degrees, right? This would be another 90, would take us down to the bottom, would be 270. So we're maybe 30 degrees short of that. So that would be 240 degrees. Or our radian version would be, where are we going to be? 4 pi over 3. In theory, you can double check these two versions with the conversions. I just don't want to take the time to necessarily go through those steps entirely right now. We'll do one last one. Let's do another sort of the version of like 45 down here. This last quadrant is, of course, quadrant 4. So I said this is like a version of 45. You can kind of see, right, there's 45 degrees sort of in between 270 and 360, halfway between. That's going to put us at 315 degrees, or in radians, it's going to be 7 pi over 4. And then, of course, we'll draw in our little, sneak this one in kind of tight, our sort of arc there to show what we mean. So standard form is just drawing in this way. So quadrant 1, 2, 3, and 4. Sort of just trying to estimate a little bit. I mean, if you're making a sketch just on your own, you're kind of doing an estimation to a certain extent to try to draw this as best you can. One of the things that happens here, right, we sort of talked about this a little bit. Let me sort of draw an angle in standard form and revisit something from before. Let's talk about our coterminal angles. So if I draw, for example, let's say like 120, right? 90 would be straight up and down. So 120 degrees would look something like that, right? This would be that, or it would be 2 pi over 3. So coterminal angles are angles with different measure, but the same terminal side. So you're ending up in the same position, right? You're just sort of getting there in a different way. So this could either mean rotating from the other direction. So if I sort of did this angle and sort of did a negative rotation to get there, so instead of doing a positive 120, I'd have to do so negative 180 would kind of take me, let me kind of just superimpose a little bit of this rest of this axis on here just to get our bearings right. So this would be kind of negative 90, negative 180, and then to get up to this 120, this is 30 degrees beyond, so this would be sort of 60 past 180. So this would be a negative 240. And so the connection here is, or the question is, so how am I sort of making the connection between this 120 degree angle and then this like negative 240 degrees? Are these just sort of random numbers, or what's the connection here? And the connection is, of course, that they have to sort of, in some sense, add to 360, right? I mean, they're sort of, the only way to end up in the same position is you need to be 360 degrees apart from each other. It's not really that they're adding to 360. I sort of meant the absolute values in some sense, 240 and the 120. They're 360 degrees apart from each other. So this is going to mean that our like angle, oh, by the way, so this is a theta. That's going to be our like go-to angle variable. We hadn't used that yet in the videos. So coterminal angle is going to be theta like plus or minus 360 degrees, or in theory like multiples of 360. You could also do a radians version, right? So you'd be sort of plus or minus 2 pi. So you can do a negative rotation. You could also do like extra full positive rotations or full negative rotations to get there. So 120, if for example I wanted to rotate, where can I sort of squeeze this in? We're just gonna have to kind of smoosh it in here. So let's say for instance I do, right, 120, then I go all the way to 360, and then I want to keep going and end up sort of back here at this like version of 120. That doesn't really look great, but I guess we'll have to make it work. So that would be a full 360 plus another 120. So my green version here would be 480 degrees. So just to sort of separate this out a little bit, right? So 480 is going all the way around, and then 120 extra, right? So it's 360 plus the original 120 to get us there. So coterminal angles, right? So what would be an angle that's like a coterminal to 120? So if I did 120 degrees plus 360, I'm going to get this 480. If we did 120 degrees minus 360, right, we'd end up at this like negative 240, which is the one that we have here. So getting coterminal angles is really just a matter of sort of adding or subtracting like multiple rotations. So doing this in degrees is pretty straightforward. You're just doing 360 sort of over and over and over again. You could kind of take it from the other direction. You could say like find a coterminal to, I don't know, something like 790 degrees. And what you would do is, instead of then adding 360, which you could do, but like let's try to find an angle that's between 0 and 360. So if I did 790 minus 360, right, I can sort of just do a quick little subtraction. That's going to get me down to what, 430? So that would be one option. If I want to get something, I think I said let's try to actually get something that's between 0 and 360. So let's go again. So if we subtracted 360 again, what are we going to be left with here? This is like 40 and 30, so this would get us to 70 degrees. So that would be sort of coterminal in like a first rotation. So just adding and subtracting 360 to get there. If we wanted to do this with like radians, we can also do that. It's not a gigantic deal. It's just that you're going to have to do some fraction type calculations instead. So like a radian version. Let's take kind of a bigger angle. Well, I don't know. What haven't we done yet? How about something like 5 pi over 4? So if I want to find a coterminal, what I'm going to do is add, what would be the equivalent of 360? Well, that would be like adding 2 pi, right? But because this is fractions, let's call it 2 pi over 1, because what we really need is something with common denominator. We're going to need something that's over 4. So this is going to be 5 pi over 4 plus a full rotation. Well, that's 2 pi, but then in terms of quarters, right, in terms of fourths, that's going to be 2 pi times 4 would be 8 pi. Part of what happens here, right, because almost all of these angles are in terms of pi, we're really just sort of working with the numbers. The pi's are kind of just along for the ride. 5 pi plus 8 pi is going to get us to 13 pi over 4. And that's the basic idea, right? You could do the same kind of thing if we started with like a bigger angle. Maybe something like, I don't know, 20 pi over 3, and we wanted to try to find a smaller coterminal angle, so that would be a matter of just like subtracting 2 pi, again, over 1, right? We're going to have to get common denominators, so that's going to be times 3 instead. So if we kind of run through this calculation, 20 pi over 3, so every 2 pi is going to be 6 pi over 3. So if we do some subtractions here, where are we going to end up? So 20 minus 6 would get us to like 14 pi over 3. That would be like what? 4 and 2/3 pi. So it's still bigger than 2 pi. So we could go again, subtract away another 6 pi over 3. That's going to get us to what? 8 pi over 3. That's in the ballpark. We go one last time, we can get down to 2 pi over 3, and that would be sort of our coterminal in the first rotation. Those angles in the sort of first rotation, so either 0 to 360 or 0 to 2 pi, those are really going to be kind of our go-to angles. Almost anything that we need to do that's for an angle that's bigger than that, most of the time, probably one of the steps in a problem that deals with a bigger angle is really just going to amount to finding a coterminal angle and just sort of subtracting your way down to something a little bit smaller. All of the different stuff we're trying to do with these angles, for the most part, a lot of the behavior is going to sync up with the coterminal anyway. So we're going to try to work with the smaller versions of the angles when we can. So that's standard position, right? Being able to sort of do some sketches. Sketch these angles in standard position on the plane, and then doing some coterminal sketches, and then just doing some arithmetic work to find a coterminal angle either in degrees or radians. There we go. So that's the end of our intro section. That's the end of 5.1.